In the spring of 1940, Britain stood alone against Nazi Germany. The Royal Air Force was bleeding pilots and planes at an alarming rate, and the American aircraft they were receiving simply weren't good enough. The Curtiss P-40 Warhawk couldn't match German fighters at high altitude, and the Bell P-39 Airacobra was proving to be a disappointment in combat. Britain needed something better, and they needed it fast. That's when the British Purchasing Commission approached North American Aviation with an unusual request. They wanted the California-based company to build P-40s under license to speed up production. But Dutch Kindleberger, the president of North American Aviation, had a bold counteroffer. He told the British that his team could design and build a completely new fighter aircraft in just 120 days, one that would be superior to anything currently flying. It was an audacious claim. Most aircraft took years to develop, not months. But Kindleberger had something the British didn't know about, a team of brilliant engineers led by chief designer Edgar Schmud, a German immigrant who had been studying every aspect of fighter design for years. The British were skeptical but desperate. They agreed to the proposal with one condition: North American Aviation had to deliver a prototype in less than 4 months. The clock started ticking on May 1940, and what followed would become one of the most remarkable engineering achievements of World War II. The team worked around the clock, 7 days a week, translating ideas into blueprints and blueprints into metal. They knew they were racing against time, and that thousands of lives might depend on their success. The design philosophy behind the Mustang was revolutionary for its time. Edgar Schmud and his team didn't just want to build another fighter plane, they wanted to rethink what a fighter could be. They started with the wing, and here they made a critical decision that would define the aircraft's performance. Instead of using a traditional thick wing profile, they chose the NACA 45-100 laminar flow airfoil, a cutting-edge design that had never been used on a production fighter. This wing was thinner and more streamlined than conventional designs, which meant less drag and higher speeds. But the laminar flow airfoil was notoriously difficult to manufacture. It required extremely smooth surfaces and precise contours. Any imperfection, even a rivet head protruding too far, could disrupt the airflow and negate the benefits. North American Aviation invested in new manufacturing techniques, including flush riveting, where rivets sat perfectly level with the skin of the aircraft. The fuselage was designed with equal care. Schmud's team created a sleek, aerodynamic body that minimized drag at every point. They paid attention to details that other manufacturers overlooked, like the shape of the air intake and the fairings around the landing gear. The cockpit was positioned well back on the fuselage, giving the pilot excellent visibility in almost every direction except directly behind. This would prove crucial in combat, where seeing your enemy first often meant the difference between life and death. The aircraft's structure used a semi-monocoque design, where the metal skin bore much of the structural load. This made the plane lighter without sacrificing strength. True to Kindleberger's promise, the first prototype rolled out of the Inglewood, California factory in September 1940, just 117 days after the design work began. It was an extraordinary achievement, but the plane they'd built wasn't yet the legend it would become. The first Mustangs, designated as the Mustang Mark I by the British, were powered by the Allison V1710 engine, an American-made inline engine that produced around 1,150 horsepower. The plane was fast at low altitudes, reaching speeds over 380 miles per hour, and it handled beautifully. British test pilots were impressed by its stability and responsiveness. But there was a critical flaw. The Allison engine's performance dropped off dramatically above 15,000 feet. Without an efficient supercharger, the engine couldn't maintain power in the thin air at high altitude, and this was exactly where much of the air war over Europe was being fought. German Messerschmitt and Focke-Wulf fighters operated most effectively between 20,000 and 30,000 feet, and the early Mustangs simply couldn't compete up there. The RAF initially used these early Mustangs for low-level reconnaissance and ground attack missions, roles where the plane excelled. It could fly fast and low, photograph enemy positions, and strafe ground targets with its 4.50 caliber machine guns. But everyone knew this wasn't the plane's true potential. The airframe was phenomenal, it just needed the right engine. That realization would lead to one of the most important modifications in aviation history, a change that would transform the Mustang from a good fighter into the finest long-range escort fighter of the war. The transformation began with a radical suggestion from a test pilot named Ronald Harker. In April 1942, Harker flew a Mustang at the Royal Aircraft Establishment and immediately recognized that the airframe was exceptional. He wrote a report suggesting that if the Mustang were fitted with the Rolls-Royce Merlin engine, the same engine that powered the legendary Spitfire, it might become the best fighter in the world. The Merlin was a masterpiece of engineering. Its two-stage, two-speed supercharger could maintain power at high altitudes, and it produced significantly more horsepower than the Allison. Rolls-Royce engineers and their American counterparts at Packard, which was building Merlins under license, began work on the conversion. The challenge was substantial. The Merlin was a different size and weight than the Allison, and it required a different cooling system. The engineers had to redesign the nose section, modify the radiator placement, and recalculate the aircraft's center of gravity. By October 1942, the first Merlin-powered Mustang took to the skies, and the results were astonishing. The plane could now reach speeds over 440 miles per hour at 30,000 feet, making it faster than virtually any German fighter. But speed wasn't the only improvement. The Mustang's range, already impressive, became legendary when combined with external drop tanks. The P-51B and later P-51D variants could fly over 1,600 miles with drop tanks, more than double the range of most fighters. This meant American bombers flying deep into Germany would finally have fighter protection for the entire mission. Before the Mustang, bomber losses over Germany had been catastrophic, with some missions losing more than 20% of the aircraft. The Mustang would change that equation completely. Building the Mustang in sufficient numbers required an industrial effort that matched the brilliance of its design. North American aviation expanded its facilities dramatically, and by 1944, the company was producing Mustangs at an almost unbelievable rate. At peak production, a new P-51 rolled off the assembly line every hour. The Inglewood plant employed over 40,000 workers, many of them women who had entered the workforce to support the war effort. These, Rosie the Riveters, became experts at their specialized tasks, whether it was riveting wing sections, installing electrical systems, or mounting the 6.50 caliber machine guns that became standard on the P-51D variant. The manufacturing process was broken down into specialized stations. One team would build the wings, another the fuselage sections, another the tail assembly. These components would then come together in the final assembly building, where the aircraft would take shape. Quality control was paramount. Inspectors checked every rivet, every weld, every system. A defect that might seem minor on the ground could prove fatal in combat at 400 miles per hour and 25,000 feet. The Packard plant in Detroit was simultaneously producing thousands of Merlin engines, each one built to exacting tolerances. The logistics of getting engines from Detroit to California, along with propellers from another supplier, radios from yet another, and thousands of other components, required a coordination effort that was itself a marvel of industrial organization. By the war's end, over 15,000 Mustangs had been built, each one a testament to American industrial capability and engineering excellence. The impact of the P-51 Mustang on the air war over Europe cannot be overstated. Beginning in late 1943, Mustang-equipped fighter groups began escorting American bomber formations deep into Germany. The 8th Air Force, which had been suffering devastating losses, suddenly had a fighter that could stay with the bombers all the way to Berlin and back. German fighter pilots, who had previously been able to attack bomber formations with relative impunity once the short-range escorts turned back, now faced a different reality. The Mustangs were faster than their Messerschmitts and Focke-Wulfs at most altitudes, more maneuverable, and they had the range to hunt German fighters wherever they went. Bomber losses dropped dramatically. Missions that might have cost 50 or 60 heavy bombers now lost 10 or 15. The Mustang didn't just protect bombers, it actively sought out and destroyed German fighters, both in the air and on the ground. Pilots like Don Gentile, Chuck Yeager, and George Preddy became aces, racking up dozens of kills in their Mustangs. By 1945, P-51 pilots had destroyed more enemy aircraft than any other American fighter type. The planes served in every theater of the war, from Europe to the Pacific, and continued in service long after 1945. But its greatest contribution was in turning the tide of the air war over Germany, making it possible for the combined bomber offensive to continue and ultimately helping to bring about the defeat of Nazi Germany. The P-51 Mustang wasn't just a great fighter plane, it was the right plane at the right time, built by people who refused to accept that good enough was good enough.